We went over this proof in class today, but I realized that there's a lot that's new here, and thinking about indirect proof is itself new. So I wanted to go over it again in a context where you could stop, pause, rewind, do whatever you need to do to get feeling comfortable with this. And so here we go. We are trying to show that from the premise P arrow Q, you can prove not P or Q. And the first question is how to do it. We can't do it by conditional proof because we're not trying to prove a conditional. We could prove an OR statement if we could prove one of its parts and then use addition, but from P arrow Q we can't derive not P. Likewise, from P arrow Q we can't derive Q. So we need another strategy. The rule of thumb is this: whenever you're trying to prove something and nothing else is obviously going to work, do it indirectly. Assume the denial of what you want to prove and try to derive a contradiction. When you get the contradiction, you will have proved the thing that you originally set as your goal. The denial leads to a contradiction. The thing itself must therefore follow. So now we know what our goal is. Our goal is to get a contradiction, but it may still not be very clear what we're supposed to do. Why not? Well, because we don't have any way of extracting information from this. We can't use modus ponens or modus tollens. We don't have any rules at this point that give us anything we can do with this, so we might feel kind of stuck. But remember what we're up to. First, we're trying to derive a contradiction. Any contradiction will do. And second, we're no longer in the situation of just having this premise. We've got the premise and a further assumption, and this further assumption is implicitly actually contradictory to our premise. The reason you know that is because I'm telling you that this proof can be completed, but that's in fact the case. Implicitly there's a contradiction here. If we can find any way to dig an explicit contradiction out of it, we'll be home free, and because implicitly we do have a contradiction, we can reasonably hope that we should do that. But what contradiction could we go for? Well, this is going to seem strange, but if we go for proving not P or Q itself, that will do it and it will work smoothly. You might think that's strange because you sort of think, well, we're already trying to prove not P or Q. But there's a difference between trying to prove it as the conclusion of our whole derivation and trying to prove it as a step in a subproof relative to an assumption that we're eventually going to put behind a scope line and discharge. So even though it seems odd, it makes sense. We want to get a contradiction between something we've already got and something we have a hope of proving. How could we prove this? Well, trying to do it indirectly wouldn't really help because we just repeat an assumption we've already got. But if we could prove not P, we would have it by addition. And even though not P doesn't follow from P arrow Q, we don't just have P arrow Q. We have something else to work with. So because we're in a different context, it now makes sense to set not P as a goal. But how? How are we going to get not P? The rule of thumb applies again. If nothing else is obvious, go indirect. I want to prove not P. I will assume P. And if I get a contradiction, any contradiction, the proof of not P will be complete. Now at this point, even if you're not exactly sure where things are going, you can at least see that from 1 and 3 we can extract information. We can do a modus ponens. So from 1 and 3, by modus ponens we get Q, and now notice from Q we can get not P or Q, which actually contradicts line 2. So we get not P or Q from line 4 by addition, and we actually have the bits for their contradiction. we could write it out explicitly on line 6. We could write out explicitly bracket not P or Q, close bracket, and not bracket not P or Q, close bracket. But for shorthand purposes and to get you used to it, we're going to use this symbol that we've been calling the perp that stands for contradiction. The justification for writing this symbol is that two available lines, and they have to be available, contradict 2 and 5. We simply write that. So our assumption of P led via what else is available to a contradiction. Therefore, the assumption of P has done its work. We can discharge it, and we can conclude that not P is a consequence of lines 1 and 2. The justification is 3 through 6, indirect derivation. Okay? We assume P in search of a contradiction. We got a contradiction. The rule of indirect derivation says we can now conclude not P. Okay, well now what? Well, remember, the reason we were trying to prove not P was because by an addition step, we can get not P or Q. From 7, by addition, we get not P or Q. Now, yes, that's the same thing that we wrote on line 5, but we had to rederive it because line 5 is now behind a scope line. It's not available. That's the point about discharging assumptions. They become unavailable because what you're trying to show is that the conclusion actually follows not from these things plus the assumption, but from lines 1 and 2 alone. So now we have a contradiction between line 2 and line 8. We can once again write the contradiction symbol. The lines that contradict now are 2 and 8. And that means that our assumption on line 2 indeed got us to the goal of a contradiction. And because 2 led to a contradiction, we can conclude rather 2 minus the additional the beginning tilde, minus the extra tilde. So we did it. We proved not P or Q from P arrow Q. What these scope lines tell us is that although we use these assumptions as ways of reasoning, 10 doesn't depend on those assumptions. 10, in fact, follows from P arrow Q itself. So this proof is a bit complicated, and it involves some things that aren't additionally obvious. What I recommend you do is let it go for a while and come back later and see if you can construct your own proof of this. You may end up with a proof that looks slightly different, or you may not, but the point is, don't try to memorize this proof. Try to understand it so you can think your way through it. And if you have any questions about all of this, let me know. But meanwhile, just to finish the job, line 10 is from 2 through 9 by indirect derivation.